Hello. In this video, we are going to be looking at equivalent sets and equal sets. So let's first look at the definition of an equivalent set. So equivalent sets essentially contain the same number of elements. Another way to talk about that is to say that the sets have the same cardinality. If you've watched our other videos, you may be familiar with this notation. It looks like it says n of A is equal to n of B, we actually pronounce or talk about it. We say the cardinality of set A is equal to the cardinality of set B. And that means that they do contain the same number of elements, and we will always disregard any duplicates. We do not count duplicates. So let's look at our first set, set A. Set A has 2, 4, 6, 8, and 10. There are no duplicates, so we're going to count all of those. 1, 2, 3, 4, 5. So the cardinality of set A is equal to 5. Now we're going to look at set B. Set B has white, blue, green, gray, and black. There are no duplicates for us to disregard. So we're going to count all of those. So 1, 2, 3, 4, 5. So the cardinality of set B is also equal to 5, which means that the cardinality of set A and the cardinality of set B are indeed equal. So if those are equal, they have the same number of members or elements, the cardinalities are equal, that means that these two sets, A and B, are equivalent sets. Let's look at the next two sets. Set P, let's change colors there. Set P has football, baseball, and basketball. There are no duplicates, so we're going to count each of those. 1, 2, 3. So that means the cardinality of set P is equal to 3. And then we also have set Q over here. We have January and February. Again, there are no duplicates, so we will count those. 1, 2. So the cardinality of set Q is equal to 2. Well, is 3 equal to 2? No, it is not equal. So the cardinality or the number of elements in these two sets are not equal. So these two sets, P and Q, are not equivalent. Our next two sets are P and F. P says X such that X is a letter in the word 7. And of course, this is set builder notation, in case you want a reminder about that. But letters in the word 7. So we're going to look at S, E, V, E, and N. But remember, we do not care about duplicates. So that means we've got an E and an E here. So I'm going to disregard the duplicate E. So now I'm going to count 1, 2, 3, and 4. So the cardinality of set P is equal to 4. There are 4 unique distinct elements in set P. Now over here, we have set F, and it is X such that X is a letter in the word vowel. So we're going to be looking at V, O, W, E, L. Are there any duplicates? No, there are no duplicates. So we're going to count all of those letters. 1, 2, 3, 4, 5. So that means the cardinality of set F is equal to 5. There are 5 elements or members in set F. So does 4 equal 5? Well, no, they are not equal. So that means that set P and set F are not equivalent. This next portion of the video is about equal sets. Equal sets are sets that contain exactly the same elements. That means that they are identical. They are identical. And something that is significant about these identical sets is that they do not have to be in the same order. So, regardless of the order. So, for instance, this picture of these five people is identical to these five people, except they're in a different order. That makes no difference. They are still equal to each other, even though they are in a different order. And of course, we still have the idea of repeating elements. We will not include duplicates. We will eliminate duplicates. Okay, let's go look and see what they have for us here. This says determine whether given sets are equal. So here we've got set A, and we've got 0, 1, 1, 2, 2, 2, 3, 3, 3, 3. Okay, again, we do not care about duplicates. So we've got a 0 to 1, duplicate 2, duplicate 2, duplicate, duplicate, duplicate. So we need to mark out all the duplicates, and then I'm going to end up with 0, 1, 2, and 3. That is what set A boils down to, which means that the cardinality of A is equal to 4. Now let's look at set B. Okay, again, we have 3, 2, 1, 0. So if we put those in order, that is 0, 1, 2, 3. And those are identical. These are identical members between set A and set B. So that means that because they are identical, that this set of sets A and B are equal. Our next problem, we are given two sets again. Set A is the numbers that are included they are natural numbers. They're limited to natural numbers. That means they will not be zero or negative numbers. They will start with number 1. And then it also says that our numbers are between 12 and 17. But it also says that their numbers are greater than the 12, but not equal to the 12, which means that we're going to start at 13. We will not include 12 because our numbers are not equal to 12. But on the other end, our numbers are equal to the 17. So that means we include 17. So our numbers for set A are going to include 13, 14, 15, 16, and 17. Okay, so for set B, we have numbers that are also in set of natural numbers. And then our numbers are going to be between 20 and 25, but they are going to be equal to the 20. So equal to the 20 means we include the 20, but it is less than 25. So we will not include 25. We will go up to 25 and end at 24. So I'm going to have 20, 21, 22, 23, and 24. Well, our question is, are these sets equal? Well, we have to ask ourselves, are they identical? Are these two sets of numbers identical? And no, they are not identical. Therefore, they are not equal. So these two sets, set A and set B, are not equal. Okay, our next set of sets, we have set A. It is part of the natural numbers, and our numbers in this set are between 200 and 206. They are equal to both of those numbers, so we will include 200 and 206 on both ends. And then set B is also part of the natural numbers, includes all counting numbers beginning with 1. We'll never include the negative numbers or 0. And set B's numbers will be between 199 and 207, but they are not equal to those numbers. So that means it's going to start at the next number, it'll start at 200, and it'll end before 207 and go up to 206. So we end up with 200, 201, 2, 3, 4, 5, and 6, and also 200, 1, 2, 3, 4, 5, and 6. And we ask ourselves, are these identical? And yes, they are identical. So since they are identical, that means that these two sets are equal. Set A and set B are indeed equal sets. Here, set A includes the elements W, X, Y, and Z, which we have demonstrated here. And we have set B, which is Z, Y, W, X. But the thing is, though, if I put B in order, then it is W, X, Y, and Z. W, X, Y, and Z. So the thing is, though, is that both of these do have identical elements because if you remember, we do not need them to be in the same order. They can be in different order, but they are still identical. And if they are identical, then that means that yes, they are also equal. So they do not have to be in the same order to be identical. Okay, let's go and look at the next set. We have a set A, which includes 4 and 5. We have set B, which includes 4, 5, and the null set. But literally, this one has two elements. Set A has two elements. Set B has three elements. Well, can something that has two elements and three elements be identical? No, they are not identical. They have different numbers of elements. So therefore, set A and set B in this problem are not equal because they are not identical. They have different numbers of elements. Now let's consider the following sets. Set A is the set of states in the United States. And set B is a set of people who are now governors of the states in the United States. So, how many states are there in the United States? Well, we know there are 50 states in the United States. So, the cardinality of set A is going to be equal to 50 members or 50 elements because there are 50 states. And how many governors does each state have? Well, each state has one governor, so that means that there are 50 governors in the United States. So the cardinality of set B is also going to be 50. Both of these sets, set A and set B, will both have 50 members or 50 sets. So because they have the same number of members, they are equivalent. That was the question. Are these sets equivalent? Yes, they are equivalent. Okay, but we're going to consider a different question. Are these same sets equal? Well, to be equal, they must be identical. They must be identical in order to be equal. In order to be equal. So the thing is, though, what are the names of the states? The names of the states are states like Tennessee. Tennessee will be in that set. Well, who is the governor of Tennessee? Well, it is Governor Lee at the moment. So are these identical? No, these are not going to be identical. The names of the governors and the names of the states are not identical. So therefore, these two lists are not equal. They are equivalent, but they are not equal. Okay, so hopefully this helps you understand the difference between equivalent sets and equal sets. Just click on the like button, click on the subscribe button, and we'll see you the next time.